Welcome back, I'm John Furrier, host of theCUBE, here at our NYSE CUBE studios. Of course, we have our Palo Alto studio connecting Silicon Valley and Wall Street. Technology is the market, and you're seeing all the stocks, you're seeing all the capital markets. We're here as part of our NYSE Wired program, a CUBE Original AI Factory series. The technology is enabling all kinds of new things, and the investors are confused, but as the industry continues to accelerate, we'll start to see visibility, agents, physical AI is coming. Sami Issa is here, founder and CEO of GlobalAI. They're building the infrastructure enablement, accelerating AI. Sami, great to see you again.
Pleasure, John.
Thanks for coming in.
Thank you.
Okay, you guys, you're the founder, so first of all, explain the founding and the mission for GlobalAI.
Oh, absolutely. Dr. John Kelly, my partner, my co-founder, and myself, a couple of years ago realized that sovereignty is going to be necessary for generative AI growth, and that enterprises and nations are going to demand compartment of compute and infrastructure for them, dedicated for it. Mm-hmm. So we said, okay, this is a strong enough reason to start a company. We both bring in massive amount of expertise in the space, mm-hmm. and we started GlobalAI, and that's what we do. We build sovereign, dedicated, not a cloud, AI infrastructure for the enterprise and for nations. I
want to get into the whole sovereignty thing. We've been kind of saying for about a year and a half that sovereign AI and sovereign cloud are merging. There's demand for kind of different infrastructures because private and public clouds are merging into a programmable hybrid cloud, which is basically private cloud if you want it.
I mean, look, I think
it's muddly, but if you're on the distributed computing network, you can slice and dice, share this hybrid, private.
No, it's probably confusing a bit. So I think, look, I mean, people, we all have witnessed the capabilities of LLM. We all have seen what LLM did to coding. The LLMs had enough examples in a public domain to learn coding and master it. And now the business model of SaaS companies and coding dependent companies is at question. So that's a clear example of why you need your secret sauce to be protected. You need your secret sauce to be air-gapped, whether you're an enterprise or a nation. You cannot have it in a public domain, you cannot have it on a cloud. You have to be incredibly paranoid about keeping that information for you only, because one thing is unique about the LLMs is that they cannot unlearn. Once they have seen your secret sauce, it's embedded within their weights, and it's near impossible to extract. Mm-hmm. And we envisioned that a couple of years ago. We started a company to cater to kind of fill that gap of creating these infrastructure dedicated for our customers, and that's what we do. It's single tenant, we're not a cloud again. I keep telling everybody, we're not a cloud.
Yeah. You know, Sami, I love this conversation. It hits multiple of my buttons. It pushes a couple buttons. One is...
I know you're a techie, John.
IBM and NVIDIA have a lot of similarities. Okay, you mentioned you guys have a deep relationship in NVIDIA, want to get to that. But a lot of people think the data center growth is just an extension. But we've been trying to dissect from NVIDIA that they're building supercomputing factories.
Yes.
This isn't just a rack and stack some stuff. No. It's completely designed. Okay, not a bolt-on. They prove that interconnects and networking, their OS. I mean, we love the factory.
You are spot on, John.
IBM has roots in big mainframes. There was a term that used to be kicked around in the 80s and 90s called big iron. Big iron was like a term that was for the mainframe. Because it was big iron in a glass house, data processing center, the information technology departments. So you have big iron, that's a supercomputing mentality. So if you take the IBM DNA, and if you see where I'm going with this, and NVIDIA is essentially big iron. I mean, they're monster systems. They're supercomputing centers.
That's brilliant insight. I wish John was here. He would have got a kick from that question. But you're spot on. I mean, 95% of data centers in the world are running on 8 to 12, maybe 40 kilowatt racks. We are building 150, 250, going to a megawatt per rack. These are supercomputers. Each GB300 is an exaflop. A couple of years ago, you and I would dream of an exaflop machine, right? Now we have many exaflops within our data centers because each rack is an exaflop. So you're absolutely right. These are supercomputers for AI. They demand enormous amount of power. And the beauty of, who was the best company that sold supercomputers to the enterprise, mainframes to the enterprise? IBM.
Yeah.
My co-founder would agree with this. A lot of our team come from IBM. IBM did a phenomenal job in the mainframe space, and I think NVIDIA is doing a phenomenal job in the AI space.
And so I brought up private cloud and hybrid cloud earlier because I wanted to get to a point there. When you add intelligence, so AI factories in these supercomputer centers, there's an implication, there's an assumption, I think we all agree that they're an intelligence factory.
Correct.
With tokens, things happen, software gets better, systems work better, systems and software working together. So when you have that kind of intelligence, you have the network up and down the stack, doesn't AI factories eliminate the need to call things private, public, on-prem? I mean, you guys are essentially not cloud, but what does that even mean? You're a distributed computing node in a hybrid network. So like if factories have all the intelligence, there's no distinction where workloads are, or is there? So how do you clear that up?
Yeah, I mean, it's a great question. So, okay, everything we see today, everything we've seen from Anthropic's, OpenAI, etc., is based on LLMs digesting or ingesting and digesting publicly available data. But the value is really in the enterprise protected data, right? This is where secret sauce is.
Yeah.
Again, we've seen the impact on coding. There was enough examples of coding in the public domain. LLMs mastered coding in a 2-year, right? And now they are, in essence, disrupting the business model for SaaS companies. You can argue whether this disruption is going to be big, small, or medium. We will find out. But there is no debate that they're disrupting it.
Yeah.
So now this is different than cloud. This is intelligence in the cloud. And do you want your secret sauce to be LLMs? Yeah. Because in the cloud, you have the right to be forgotten. In the LLM world, you do not have the right to be forgotten. You cannot unlearn. You cannot convince an LLM to forget the learning. It's near impossible. Yeah. So we started that company with that key insight that enterprises are going to realize that you want to protect your secret sauce way more than you did before. And you are going to demand that compute to create the creativity and productivity enhancement. You cannot have it in your own data centers because it's really complex. So we will build it and dedicate it for you and air gap it from anybody else. And we have customers who demand to be the only customer in the whole data center. They say, we don't want anybody else, small, big, or medium. We want the entire data center for us only, not just the data hall, not just the compute, the entire data center.
You remember the old days, you had intranets, extranets, DMZ, demilitarized zone, which is a network nomenclature for kind of like an area where you have to play both sides. You apply that to the whole cloud notion, it kind of goes away because what you guys are doing is essentially building AI infrastructure for enterprises. Correct. To treat as a node or an extension of their premise. Exactly. Whether they're in the cloud doing data processing, you are a trusted node in their network as a factory node. And NVIDIA is powering that.
100%, perfect summary. We are your compute that you couldn't have on your prem because for the reasons that we just described. It's too complex, too expensive. And by the way, you don't have to CapEx it. We CapEx it for you and it's OpEx to you, which is, CFOs love that. Yeah.
And so now I want to get into what this means for the customer. So let's just take through a scenario. I've been writing and commenting about the moats, strategic moats. In fact, just IBM stock dropped because someone wrote a post that said Anthropic can do COBOL, which, I can do COBOL, but I can't build Z mainframe. So you have this unlock. What are some of the use cases? Because agents now are end-to-end workflows. So I want you to talk about the importance of having this private supercomputing, whatever you call it, AI infrastructure. Because when you start getting into agents, that has the whole intra, DMZ, extranet issue of cross-domain traversal. So if I'm writing agents for an enterprise, so that's happening. And then the unlock of how much of that private data is not yet been AI-ified.
Yes, exactly. Meaning but not been LLM'd yet.
Hasn't been trained. So how are enterprises thinking about their architecture? That agents are going to be going all crazy, doing good things. I mean, data's going to be unlocked on-prem in a secure environment.
I mean, look, I know your tech background is refreshing because you ask deep questions, and I like that. I think what we are hoping to provide to our customers is the safe environment where they can build, train on their secret sauce and create their agents, their tools, their flows that benefits from the wisdom that they have embedded in their data set, in their own private networks for decades. It is difficult for me to imagine that a drug discovery company is going to want its data in any of the public LLMs.
No, that's clear. It's private LLMs for them.
But then every enterprise has some secret sauce that is the shareholder value creation is built upon. None of them, drug discovery is an obvious example, but I think none of the enterprises with secret sauce want to have their secret sauce absorbed in an LLM. So what do they do? They cannot build it themselves because it's too expensive, too complex.
And time consuming.
And very time consuming. And by the way, Jensen is doing a refresh every 12 to 18 months, which is insane to keep up with. I mean, we have the GB200s and GB300s running. Vera Rubin is coming up in April. And we are running like mad to keep up.
Talk about the relationship with NVIDIA. I think this is super important because what they're investing in, it's very clear. They're not holding any cards back. They're like, play it all out there. The enterprise is huge for them. And that's new for NVIDIA. They never really had that. They had the gaming, they had Bitcoin mining, they had that supply and ecosystem on the side. But now you have enterprise AI, whole nother ball game for NVIDIA. As they think about the enterprise, of course, why wouldn't they? They're not going to knock it. They're going to knock it down. NIMS, NEMO, all good stuff. We cover that Omniverse, great for training physical AI. So clearly NVIDIA gets it. But they're kind of new to the enterprise. How is your relationship with NVIDIA? Are you an early partner? Are you co-designing with them? Radical co-designing, as they say?
We are very, very close to NVIDIA. They have been a fantastic partner to us. As I mentioned, we are, we can, because we are technically strong, we have a very strong technical team. We can build these liquid-cooled data centers ourselves. We can bring up the bleeding edge technology online, as I mentioned, GB200s and 300s.
So you have good supply chain access.
We have the supply chain access, but also more important, we have the access to, equally important, the access of the brain trust within NVIDIA where we can, because these machines are complex. They're unlike anything that I or you have seen before. Like you mentioned earlier, they're supercomputers in a rack. So they're not easy to bring up. You need to spend, you need very, very qualified people to spend enormous amount of time to bring these machines up. And without NVIDIA's brain trust helping us and Supermicro, our partner, we cannot bring them up.
And you guys are building the physical plant too. It's not just you're dropping in an NVIDIA box. You're engineering the facility, the power.
We fit it out, we put the pumps in place, water pressure in place, electrical, everything from the ground, vertically integrated. I was talking to an investor a couple of weeks ago, and he said, there are 300 individuals in the world, 300 in the world who can actually build at scale GB300s today. And that is the best, the most accurate description of the market today. This is not 3,000, 300 across planet Earth.
All right, talk about the demand side from your business. You guys got great momentum. Obviously you got a product market fit. I'm sure the demand for that private on-prem AI, extended on-prem, it's kind of an extension, so it's basically on-prem in the category.
Exactly, exactly right.
Talk about the growth. What's the demand look like? Just share some anecdotal, and then other approaches. Some people are taking the whole, we're a neo cloud, we want GPUs here, and they're basically white labeling data centers. What's the difference in this market?
I mean, look, demand is unlike anything I've seen in my entire career. Demand is unbelievable. If I go to the market with 500 megawatt, it will be gone within a couple of days. If I go to the market with a gigawatt, it will be gone within a week. I'm not talking about.
I mean, the hyperscalers buying too. Everyone, Meta, Amazon,
exactly.
Google.
I'm not talking about speculation. I'm talking about 3, 5, 6 years contracts with investment grade companies that need that demand for their growth and for customers. So demand is off the charts, anything and everything. We're running like crazy trying to bring as much demand as possible, as much supply as possible to the market. So demand is off the charts. And I think-
So you're building like crazy.
We are hovering power across the nation, and we're looking outside the-
share the footprint and what your goals are and what your growth strategy is.
I mean, look, we are looking at building about a gigawatt in the US by 2029, a couple of gigawatts here and outside. We have partnership in KSA, in the Kingdom of Saudi Arabia with Humane.
You're building a global network. Hey,
That's
global
exactly
AI.
Global, hence,
Hey.
hence the name. Hence the name.
But you see these centers as hubs or independent units? Are they networked together? I mean, imagine you're basically building private factories.
Exactly. They are not networked together. They're dedicated. And even if we have, from experience, if you have, which is the case, if you have a customer that has a footprint here in data center A and in location A and location B, they don't want them connected in the background. They're going to connect them at their hub. So they're not connected yet.
So you guys are running hard, funding, feeling good about that?
Funding is great. We went to the
hot.
market a couple of times last year. We raised money super quick, few weeks. Combination of debt and equity. Debt is against contracted revenue, so we don't do any speculation building. Everything has a contract, has a customer, has contract revenue. Everything's investment grade. So it's a fantastic place to be.
You know, one of the things that we have a vision on, we're tracking, obviously the AI factories, central factories, distributed nodes, whatever node it is, big, small, medium. Edge is coming, and then metro. We see metro factories coming. So when you have these connected intelligence devices, supercomputing, enterprises start to behave differently. They're essentially redesigning their network. So I, as an enterprise, could say, hey, I got to have a global footprint, tap global AI, and run my own workloads.
Yeah.
Okay, in a distributed computing fashion. That's pretty much where you guys see the puck going.
Yeah, I mean, look, the end state, I think, the end state is going to be, AI intelligence is going to be utility, like electricity.
Yeah.
You're going to plug into the wall and give intelligence, right? Where it comes from, does the execution happen 50% in the edge and 50% outside of the edge, or 20-30, depends on the workload, depends on the latency needs, depends on the compute need. The compute still takes enormous amount of time. I mean, if you look at 6 seconds, probably 3/4 of that is compute, not latency. So we're still not at the latency edge point yet for most big workloads that we have seen.
Well, Sam, you guys are doing a lot of hard things. One, identifying locations, building out these data centers / supercomputing centers, AI factories. For the people that don't know the complexity, scope what it's like, not just to get real estate and plug in the power in the wall and spin up a rack. You guys are designing AI factory systems.
Yeah.
So every piece of material, every piece of power you're squeezing out of it. Talk about the design that goes into the engineering of that. Just scope, the order of magnitude, so people don't understand, like, why is this so hot? What's the big deal? Just get some power, plug in a rack. Talk about the difference between how hard it is.
I wish it was that easy. I'll give you an example. We're building a gigawatt data center. Gigawatt is a big number, right? Now here's the scary part of this. These chips are burning so much energy and producing so much heat that we have to cool them with liquid. That liquid that has to reject that 1 gigawatt worth of heat comes all the way to the chip. So you have millimeters, less than millimeters, between a gigawatt of electricity and water. And make one mistake, and single mistake, and the end result is catastrophic.
The density, the heat.
Density, heat, the proximity of liquid and electricity is something that we've never seen.
These are like substations, like electricity. These are highly engineered power
plants.
Token power plants.
A gigawatt is a typical nuclear reactor output. Right? A nuclear reactor is in a 1.2, 1.4 gigawatt.
Yeah. Well, Sam, you got a great venture. Looking forward to meeting your co-founder from IBM and get more deeper dive on that. For the last minute we have, put a plug in for the company. What are you looking to do? You're hiring?
We are hiring like crazy.
Give a plug.
We're looking for talent, entrepreneurs, intelligent people across the spectrum. We're growing. I mean, we're adding, 20, 30, 40 people a month now. Building like crazy across the nation. We're looking outside the country. We're looking for power. If you have power, call me.
You're open for business.
We are open for business.
All right, Sam, appreciate it. Global AI, again, this is the wave. It's the global infrastructure. Sovereignty is where people want to have their customization, get their privacy, private AI, super AI, it's all happening. Enterprises want their own infrastructure in distributed computing. We're doing our part in theCUBE, bringing that to you. I'm John Furrier, the host. Thanks for watching.